cable will work, won't it?
You won't get justified.
No. We're going to go for the double insulated single cores if we go anything bigger than 16 mil. And at that point, can you imagine trying to do that into a shower?
Don't talk about showers, man. He's getting the other fella off yesterday, but he's not even here today. He's probably sorting all that now.
Well, this is the difference when you start including all these different factors. Now, there's one great way that we can actually reduce this down, okay? And that's just by changing the protective device.
So if it was
If it was a BS60898, it suddenly changes the calculation down to 51. See the massive difference FuseWire actually has on this circuit. It takes it from 70 amps down to 51 amps. Okay?
so instead of having a fuse, a variable fuse, have a circuit breaker.
Yeah.
Yeah, separate.
Just by that one simple change, that one correction factor, it suddenly changes everything. The fact that because it's running through a loft, why not run it up onto the joist and along so it's above the insulation? Okay, you with me? So it's run above the insulation. When it comes down, you put a piece of big pipework in to give it space so the insulation doesn't actually touch it. You suddenly take out the 0.78 as well. Just by changing a few little details, how that cable is run through a loft, you can suddenly start to reduce the actual size of cable needed for it. Okay, crazy thought that, isn't it? Slight little changes on the way we run them. So if you take it out of thermal insulation, run it above it, right? You run this above the thermal insulation. Let me just make that accurate and actually change that to 32.
Yeah.
Takes it down to 42. A couple of little changes about the methods in which we install it make a massive impact on the current on the effects the environment will have on that cable.
Is that about saving money or is that about safety?
Both, really, isn't it?
Both.
Why can't you do both? Why can't you save money and install it just as safely? It'll just bring the heating bill up, won't it?
You're on single?
Okay.
1 mil.
If we were to carry on with example A, we can't really carry on much further. It would depend on whose interpretation is right. If you go for reference method C, you could carry on. If you do go for the reference method 100, which is also quite right as well, right? You can't actually install it. Okay. The reality is, though, that if we go down the reference method C method, we have already taken into account that insulation, haven't we? Because we've got the correction factor, so that's why we can go down that route. Okay. Designing isn't a simple yes/no exercise. It is massive interpretation by the people sat with the books in front of them, and you can interpret the regulations in multiple different ways. And just looking at that table, you can interpret this as either choice. My personal preference is because we've already applied the factor for the thermal insulation, I'd go down the route of reference method C. And that's how I can justify that. I don't know, I'd say it's more likely a surveyor who picked out the wrong materials. Okay. Grenfell was the fridge freezer with a plastic backing. The
Sabotage.
arcing from the machinery caught the plastic backing, the kitchen went up and the guy was in the flat and just walked out.
I like fibre.
What's that?
On your fibres, but when that is fucking good.
I was amazed at the fact that we have these big blocks of flats around London and everywhere, that we don't have the firefighting capability at the time to reach up that high.
None of them have got all the blocks of flats used to have their own hoses, didn't they, in each floor?
It had it, but it had the wrong type installed.
Yeah. I think the outside clad, didn't it?
The
It's
cladding.
the outside clad. Has anyone here ever set light to a sponge?
Yep.
Basically, think of that, and that was what was wrapped around that building was a sponge. But it wasn't just a case of it's a sponge on its own. You put a sponge between two pieces of metal. Okay, what happens to heat? It rises, doesn't it? Okay, so the air going through two pieces of metal that's now being heated suddenly rises up, which draws more air through, actually creates a super fire because of the fact you're charging the air through it now, and it's being charged by its own force. So it's being superheated because of the airflow.
Have you ever driven near it or driven past it?
Yeah.
Quite fucking eerie.
Okay.
I want to say something. I don't know whether I've got my facts right, but you know Grenfell, there was a documentary in Australia called Inferno. Something exactly the same happened in Australia, and I think it happened before Grenfell.
Yeah, there was actually about 5 fires in the UK beforehand that they'd identified the cladding as being dangerous.
They put it on Bedford College, and there was a woman called Claire. She stood outside with a megaphone saying, "Take this cladding down, take it down." And she was going around the country trying to make a bit of money as a surveyor, getting the cladding down. But she never done it in time. Grenfell went up in fire.
I can believe it. Okay. Right, so, are we all happy with what we're doing so far? Okay.
So that's a shower circuit. A ring circuit, do you just say as many plug sockets as you want in 100 metres square?
Within reason, yeah.
So
You
you don't.
wouldn't put 100 sockets on a one ring circuit because you know you'll get an overload.
So just a bit of common sense with a ring circuit, yeah.
Bit of common sense, but with a ring, we'll get onto that in a minute. Are you all happy with how we go on to select the cable with this? That it's just a case of we work through, we get our factors, and we start to apply them. Little tweaks and changes, we'll be able to reduce these down to workable levels. Okay? Something as simple as just changing the protector device. The hardest thing is to justify a circuit on a fuse wire is when you look at like 1mm cables on lighting circuits, it doesn't actually comply when you calculate it through because of the correction factor of the 0.725. It just kicks that current up so high that a 1mm cable isn't actually able to provide that protection. Okay? That's it, and that's the problem. Okay? So what would be the solution for the fuse wire?
Change it to a circuit breaker.
Change it to a circuit breaker or an RCBO. My personal preference is I'd go down the route of RCBOs.
Are they both the same?
Trouble is, to do that, you'd have to have a new board.
Yep.
Because
But the reality is, if you start looking at these circuits, so a shower circuit, what location is it installed in? In a wet location, special locations. What's the requirement for any circuit being run through a special location? Additional protection. Does fuse wire provide additional protection? No. So unless there's an upfront... Huh? I know. So you start looking into the regs detailed enough. Fuse wire, I don't know why they still get to teach calculation with fuse wire, because unless there's an upfront RCD module, mate, it doesn't comply any day. Whereas an MCB design will comply. Okay? Does that make sense? Now, I know I was being asked about the ring circuits. Okay? Calculation on a ring. Okay, this is copied straight from the regs books. Okay? So, in designing a ring circuit, we have to make sure that, be it a 30 or 32 amp circuit, that we are looking at the fact that the IZ of the cable must not be less than 20 amps. To calculate the IZ, the formula is IT, which is the current carrying capacity of the cable, times by the correction factors. As long as our IZ equals more than 20, it means that the situation is suitable. Okay? If that calculation becomes less, okay, it means that it's not suitable for the environment that we're working in.
We
Okay.
haven't got that.
We haven't got that.
That's the one that I gave you a piece of paper yesterday for. Because when I was going through it, it didn't actually have a ring circuit.
If we get a stapler, we staple that together.
Yeah, you can have the stapler, but they pinched the staples out of it earlier on today, as well as the spring.
Bloody hell.
Have you got one of those printouts from Dispatch?
I'll have to print one off. I've got to print one off for someone else, but I don't think it is today. So I've got it ready to tap that. I just haven't had a chance to. Okay. So what this would look like is this. Okay. If we were to take a cable which has the temperature correction factor of 1.03 and a grouping factor of 0.7, okay. If I go to table 4D1A, which I believe is looking at single core cables. Single core cables, okay. My 2.5mm cable, which is run in conduit, okay, has a current carrying capacity of 24 amps. Does that make sense? Okay.
Where you look at, sorry?
4D1A, which is on page 401.
Yeah, I've got that. Yeah.
Okay. You're looking at reference method B, and it's single phase. So two single phase AC or DC. When you follow that down, the 2.5mm cable is able to carry 24 amps. Does that make sense?
It's what?
Say that again.
Able to carry 24 amps.
From reference method A.
B. B, it's enclosed in conduit.
Sorry,
Yeah.
Okay. So on a ring circuit, when we're doing this, okay, we take the environmental factors, which I've given you the environmental factors for this one to make it easier for me. If we take the ambient temperature factor of 1.03 and a grouping factor of 0.7, when we multiply 24 by 1.03 and 0.7, we get an answer of 17.3. Okay?
Yeah.
Which is less than the 20 amps stated in that regulation, isn't it? Okay? Does that make sense? So 24 times by 1.03 times by 0.7 will equal 17.3. If you remember the regulation we looked at a second ago, this one, okay, it's got to be designed that every point of the circuit must be able to carry 20 amps. Okay, that calculation has just shown us that if we were to use a 2.5mm cable,